everybody, this is Mrs. Lehman with Math with Mrs. Lehman, and I'm here in my 6th period class. Hi. Today we're going to learn about least common multiple, or for short, LCM. Our first problem involves buying hot dogs. Hot dogs come packed 10 in a package, so we should underline that. It says hot dog buns come packed 8 in a package. Alright, so you've got hot dogs in packs of 10. The hot dog buns are in packs of 8. And we are being super picky because we want one hot dog for each bun for a picnic. We're not feeding our dogs any of our hot dogs, okay? No leftover buns, none of that stuff. So we can't have anything left over. Every hot dog has to have a matching bun, okay? And we got to figure out what is the least amount of each we need to buy and how many packages of each item we would have to buy. So we are going to find the LCM of 10 and 8. So let's label this hot dogs and buns. Alright, so 10 is for hot dogs, so we're going to count by 10s. Ready? Everybody, let's go. First one. 10, 20, 30, 40, 50. We could go on all day, right? Buns, they're going to go in packs of 8, so let's count by 8s. We're going to have 8. What's next? 16, 24,
32.
Oh, why did I write 36? Back up. All right, 32 and 40. Okay, so we have hot dogs in groups of 10, buns in groups of 8. We obviously landed on what number in common?
40.
40, very good. So 40 is our LCM. So we need to buy 40 hot dogs and 40 buns. So that's right, we need 40 hot dogs. How many packages of hot dogs are there if we're buying 40? Michael?
4.
4, very good, because this is package 1, this is package 2, this is package 3, this is 4 packages, right? So we need 40 hot dogs, which is 4 packages, and 40 buns, which is how many packages?
5.
Very good, 5 packages. Right, so there you have it. So yesterday I talked a little bit about having a hair appointment with someone I used to work with, and she went in every 6 weeks. I went in every 4 weeks. We expected to see each other again 12 weeks from then. And we figured out that I would be receiving I'd be on haircut number 3, and she'd be receiving haircut number 2 at that point, right? So you really have to read the questions carefully to make sure you're answering it fully, because a lot of times it's not just about finding LCM, it's about maybe figuring out how many multiples of that number you had to go, if that makes sense. A lot of these LCM questions do not tell you that you need to find the LCM. There's not a great number of key words here, so my advice to you is to look for any situation where you're looking to land on the same number, where you're looking to find where certain schedules align, or anything that has a rotating or a cyclical pattern, and it needs to match up with another rotating or cyclical pattern. Does that make sense? So in this case, we're just buying so we don't have any leftover hot dogs or buns or whatever. But this next question is a good example of where we would use it in more of a scheduling sense. It says, starting at 6 a.m., a bus makes a stop at my street corner every 15 minutes. Also, starting at 6 a.m., a taxi cab comes by every 12 minutes. What is the next time there will be a bus and a taxi at the corner at the same time? All right, so let's underline the key things. Who can tell me one thing we would like to underline here? Maddie?
The bus makes a corner at 15 minutes.
Every 15 minutes for the bus. Very good. Is there anything else in that sentence that's very important? Lonnie?
6 a.m.
Very good. That's the starting time. So it's going to show up at 6 a.m. and then 15 minutes, a bus comes by, another 15, another bus. It says also starting at 6 a.m. a taxi cab comes by every 12 minutes. What's important there, Abby?
12 minutes.
Very good. 12 minutes. And we should underline that that's a taxi. And then also what's important with that, Tara?
Common multiple?
Nope, it doesn't say that. Tara's going to pause on this one. We're going to come to Paula.
6 a.m.
Very good, 6 a.m. So we know the starting time. And it says, what is the next time there will be a bus and a taxi at the corner at the same time? So we got to figure out the time that they meet, okay? So we need to find the LCM of essentially 12 and 15. So there's two approaches here. You can either find how many minutes it's going to take for them to meet up again, or you can just start counting, writing the times down. Okay, so maybe we do this. We say the bus and the taxi. Right, so the bus, we could start it at 6 o'clock, right? And then when's the next time that bus is showing up? 6:15, yep. And the next time would be what? 6:30 at 15 minutes. Then it would be 6:45 and then 7 o'clock. Let's pause there while we figure out the taxi schedule. All right, so the taxi is also going to start at 6 o'clock a.m. When's the next time the taxi is showing up? 6:12, very good. The next time would be 6:24, nice job. The next time would be 6:36. Next time, 6:48. And they would bump into each other at 7 o'clock. So 7 o'clock is the time, 7 o'clock a.m. What was that? Very good, Xavier. Every hour they're going to bump into each other. So I saw some people on their papers, Olivia for example, she had this. She had bus 15 and the taxi 12. Oops. Right, so she did 15, 30, 45, 60, 12, 24, 36, 48, 60, and she said 60 is a match. Now the question though is what time, so you need to relate this. This is 60 minutes, right? So 6 o'clock a.m. plus 60 minutes, plus 60 minutes, we'll bring that to 7 o'clock a.m. Does that make sense? All right, so you have two options there. Personally, I think if you're dealing with a schedule, it may be easier just to do the times, okay? And just count out the times. All right, we're going to flip the page. There's another problem I'd like to do with you guys regarding gears on a machine. Do you guys know what gears are?
Yeah.
All right, so they have little teeth, and they, go together. So it says, two gears in a machine are aligned by a mark drawn from the center of one gear to the center of the other. So this is one I definitely want to picture. We have two gears, they're aligned, essentially, and it says, if the first gear has 24 teeth, and the second gear has 40 teeth, how many revolutions of the first gear are needed until the marks line up again? So one more time. Two gears in a machine are aligned by a mark drawn from the center of one gear to the center of the other. If the first gear has 24 teeth and the second gear has 40 teeth, how many revolutions of the first gear are needed until the marks line up again? So this is a prime example of a question that you'd use LCM for, but it doesn't really tell you to use LCM. You have to figure out, we have something that's physically, in this case, rotating, and we're looking for where it's going to meet up with another thing that's rotating, okay? So, let's see. So, we're going to find the LCM of 24 and 40 because I'm going to draw a little diagram here. All right, so there's the gear. I'm not drawing all the teeth in there, but it's going to take 20, it's going to rotate over 24, right? So that's 24. The next loop would be what? 48, and it's going to keep going like that. So 24, 48, what's next? 72. What's next after that? 96, good. What's next after that? 120, thank you, Kaden. All right, 40, let's count by 40s. This is much easier. 40, 60, not 60. Why did I put 60?
40, 80.
Back it up. All right, so 40, 80. Why is someone so like that? All right, 40, 80, 120. So you keep adding, to do this, you just keep adding that number repeatedly, okay? So that's why it's called a multiple. You're multiplying by 1, by 2, by 3, by 4, etc., etc., etc. Yes?
I remember by just looking at the numbers, just taking out the zero or any extra number and just counting it, just adding the zero with it.
You're right. That's a very helpful tip. Lonnie said that she just essentially is counting up by 4 and then tacking the 0 on the end. All right, so good work. All right, so 120 is where they meet. It's the first time they meet. So the question asks, though, how many revolutions of the first gear are needed until the marks line up again? How many times is that gear going to go around to get to pass 120 teeth? Maddie?
5.
5, very good. So we're going to say the first gear will revolve 5 times. Right? Just as a side question, how many revolutions of the second gear will we need? Heard from Rihanna. Rihanna? 3, very good. Yep, so 40, 80, 120. 120 is the result of multiplying 40 by 3. All right, any questions on this? Yes, Lonnie. How did you get 5 times? Good question. So, okay, so this is 24 times 1, right? So that's 1 revolution. Times 2, that was our second revolution. Times 3, times 4, times 5. Because 24 times 5 is what gave us 120.
Oh.
Great question. Any other questions on that if you're not understanding? How are you guys feeling about this? Okay or not? All right. We're going to answer a few more quick questions. Then I'm going to show you guys some stuff that you can use on Google Classroom. All right. So question D says, is the LCM of a pair of numbers ever equal to one of those numbers? So can we ever have a situation where the two numbers, you're going to get an answer that's one of those numbers? Can someone give me an example? Lorelai? 2 and 4 would work. Very good. So 2 would be 2, 4, right? And then 4, you would just have to do one jump to 4.
Wait.
Can you give any other examples where this works? Xavier? What? 15 and 30. Very good. 15, you'd go 15, 30. For 30, you would go just a 30, right? So I love these because you only have to multiply by 1 for one of your two multiples. All right, why does that work? Or when does that work? When one number is something. Lonnie? Okay, well, you're going to have one number bigger than the other.
Oh.
But, Evan?
Equal.
No. I mean, 2 and 4 are not equal.
When one number can be divided by the other number.
So, what's a fancier way of saying that? When one number is a blank of the other number. Very good. Yeah, you're a little hesitant to say it, but you're right. When one number is a factor of the other. So when 2 is a factor of 4, 15 is a factor of 30. Or you could say when the bigger number is a multiple of the smaller number. You could say it either way. All right? Yes. Can you what?
For homework, is that basically what we're going to do?
For your homework tonight, you're going to actually have 3 numbers. And some of them you're going to have just find LCM of some pairs of numbers, but then there's a few examples where there's 3 or 4 numbers. So just think about that, like where would all of the numbers meet up, okay? Not just 1 or 2, not 1, not just 2, but like 3 or 4, I should say. All right. The next question, is the LCM of a pair of numbers ever less than both numbers? Can you ever get an LCM that's lower than these numbers that you have? Everyone's like shaking their head no, but no one wants to say it out loud. All right, so the correct answer there is no. And the reason is we keep kind of scaling those numbers up because when we're dealing with positive numbers, we are, I'm going to say we're scaling it up. We're multiplying. For the multiples, I'll say. All right, so there you have it. All right, guys, if you could go ahead and find the LCM of 15 and 12 and 15 for the exit ticket here. I'm going to pause this video. I'm going to get what I need set up to show you guys the quizzes and Quizlet stuff, okay? So stay tuned. All right, guys, so you had to find the LCM of 12 and 15, which is 60. Nice job. Okay, so you have a test on Thursday. So I'm going to show you guys a helpful resource that you can use. All right, so here is our Google Classroom, and if you go to either the streams, you scroll down, you can see that I've added some things that you can, some links to click on, or you can find them also in classwork. I'm going to move these to the top. All right, so we have quizzes and Quizlets, which I think most of you have used before for Module 1 stuff, right? We've talked about this before. Anyway, so for example, if you click on this link, it's going to take you to a lot of greatest common factor questions, all right? So this would be a great thing to practice. It'll tell you if you are correct or incorrect. So that's one of the links. Another link that you could do is LCM and GCF. So these are all like little just quizzes. Like that's the name of the website, quizzes. But anyway, then there's also a Quizlet, and I wanted to practice some stuff with you. So Quizlet is pretty much utilizing like a flashcard kind of thing, matching, like every word has a definition. So if we click on that, I'm going to X out of this. All right, so we could do flashcards, or we could do a matching game or a test. So let's practice with the flashcards first. So I'm going to show you how this works. It says multiple. If you click on the word, it will say it out loud. Oh, it did before. Why not?
Check your volume.
What happened?
Check volume.
Well, either way. Oh, there, now it'll work, I think.
The result of multiplying a number by an integer.
Does anyone know what that is?
No.
That's a multiple.
I got it.
It's a multiple, all right? So that's one example. Let's go back to the beginning. So flashcards, again. All right, answer to an addition problem, everyone.
Some.
Very good. So then you go to the next one. Answer to a multiplication problem is? You guys are good. All right, answer to a division problem.
Answer to a division problem.
All right, his quotient. The next one, answer to a subtraction problem.
Difference.
Very good. Step-by-step solution.
Part to whole.
A step-by-step solution, how you solve something, like division. There's a step-by-step process. Begins with A. Algorithm. All right, so that's one thing. Another thing you could do that may be helpful is a matching game. So answer to a subtraction problem, difference, so you got to match them up and they'll disappear. And then there's another one, you can do a test and it will turn all of these things into a test and it'll tell you what your percentage is. So other than doing some of the calculations, doing these quizzes, on the quizzes, Quizlet would also be another resource. So anyway, it is time for us to go. So I'd like to thank you for watching. Don't forget to like and subscribe. Have a great day.
Bye.